Hi dear learners, I'm Zinnah. I welcome you to our another topic. Today's topic is electrolysis. And now the word electrolysis is a compound word. I mean, you can break the word into electro and lysis. Electro here, electricity, and lysis is analysis. So electrolysis is an analysis using electricity. Electrolysis basically is a decomposition reaction. And a decomposition reaction means a compound decomposes to give smaller or simpler substances. Suppose I'm giving an example. Calcium carbonate here. If you heat calcium carbonate, it decomposes to give you calcium oxide and carbon dioxide. As this is caused by heating, so we call the decomposition thermal decomposition. But not always decomposition occurred by heat or thermal. And another example you get here, suppose sugar or glucose. Glucose is decomposed by adding yeast and bioorganism called yeast. When you add yeast to sugar, it decomposes to give ethanol and carbon dioxide. As this decomposition caused by bio or bacterial activity, we call this biodecomposition. And here you get your term electrolysis, which is also a decomposition reaction, but not caused by heat or not caused by bioactivities. We call this electrolysis. This is basically caused by electricity. Now you get a condition to pass electricity through a compound, which is the compound should have mobile ions. And where do you get mobile ions? Ions you may get in any ionic compounds, but ionic compounds may not have mobile ions. You first need to melt the ionic compound, or you can dissolve ionic compound in water to make aqueous solution. If you get molten ionic compound or aqueous ionic compound, you will get their mobile ions. So this liquid with mobile ions is called electrolyte here. So with all the concept, now we can define electrolysis as electrolysis is a process to split a compound into simpler substances or elements by passing electricity through its aqueous or molten state. Look at the definition. This contains three parts of the definition. One is the compound splits into elements. Another is you need to pass electricity through the compound. Another is to pass electricity, the compound must be liquid or aqueous. Now, how to pass electricity through the electrolyte? If you just use metallic wire, electric cable here to pass electricity through the electrolyte, you may have two of the problems. One, the electric wire, which is metallic cable, may react. Another is the metallic wire normally are very thin. When you pass electricity using the metallic wire, as it gives very small surface, so the reaction will be very slow. We may solve the problem using graphite. Graphite is a form of carbon which is a very good conductor of electricity, and graphites are also cheap. So use two graphite leads to pass electricity through the electrolyte. You get those two electrical leads to be connected with the battery and pass electricity through the molten liquid. The electrical leads of the carbon graphite we're using, they are called electrodes. And two electrodes also have different names. One is cathode, another is anode. Cathode is connected to the negative terminal of the battery, and the anode is connected to the positive terminal of the battery. To understand the reactions occur in electrolysis clearly, you first need to be sure about the role of the battery we connect with the electrodes. Here the battery is a pump. This pumps electrons. This pumps electrons from anode to the cathode. When this happens, then electron density of the cathode increases, and this also causes the electron density of the anode decreases. So when they're connected to the battery, the cathode become negative because there are more electron density, and the anode become positive because the electron density is less. And what's next? Very simple. Just use common sense. At cathode, all the cations move to the cathode, and cations are cations because they have less electrons, so they are deficient in electrons, and they move to the cathode, which is rich in electrons. So when the electron deficient ions move to the electron rich surface, so certainly there they will gain electrons. The cations, when gain electrons, there are no more cations because a deficiency is solved. So they will be atoms. Suppose giving you example, calcium ion here, which is Ca2+. This moves to the cathode and this gains 2 electrons. So these 2 electrons we write on left side as calcium ions gaining electrons. So this gives you calcium metal. And you could have any other metal ion. Suppose here could be sodium ion. If sodium ion is there, that also moves to the cathode and it needs electrons. So this will gain an electron. We write this electron on left side. And this is how any metal ions, cations, will gain electrons at cathode to form metal. As the cations are gaining electrons here at cathode, so we call the reactions reduction reactions. Now look at the reactions at anode. At anode, oxidation reactions take place, which means the anions lose electrons here because the anions are anions because they have more electrons, and when they move to the anodes, which is deficient in electrons, so anions will certainly lose electron there. Now after the anions lose electron, there are no more anions, they form atoms, neutral atoms. If you look at the reactions occur at cathode and anode, they are opposite, they are different reactions, but somehow the reactions are similar. Where's that? The ions become neutral atoms. So at both the electrode you get the ions convert into the neutral atoms. Now let's think what would happen to the atoms when they form from the ions. And initially you first think of the cathode. At cathode the metal atoms form from their ions, cations. You know, when metal ions form or convert into metal atoms, they actually form metals, and metals are solid. When metals are solid and they are forming at the cathode, which is graphite electrode, that is also solid. So at solid surface another solid is formed. So the metal will coat the electrode of the graphite, and gradually the cathode will be thicker, and appearance of the cathode will also change, because you know the cathode we are using here of graphite, which is black here, and then when metal coats the graphite, then the cathode will turn into metallic color. You know, most of the metals are shiny gray, so here the color will change as black cathode turns shiny gray. But if you get any colorful metal, suppose gold here, then the black cathode will turn golden. Now let's see the atoms formed at the anode. Normally some elements are diatomic molecules. You know, the halogens are the most common examples. If you think about chlorine, that is Cl2. If you think about bromine, that is Br2. You never get chlorine and bromine as Cl and Br. They are always diatomic molecules. That Cl2, Br2, I2 is, if this is for iodine. And not only halogens are diatomic, there are many other elements also diatomic. Look at the elementary gases: oxygen, O2, nitrogen, N2. They exist in nature as diatomic molecules. So when these atoms form there at the anode, they certainly pair up, as the atoms do not exist in nature as atoms, so they pair up to form diatomic molecule. I'm giving an example. Suppose this you think for oxide ion, O2 minus. When O2 minus approaches to the anode, then there this loses 2 electrons to form first oxygen atom. Then 2 of the atoms will combine to form O2, then leave the electrolyte, and we can write the equation together as 2 oxide atoms together lose 4 electrons to form 2 oxygen atoms first, then they combine to form O2, and that's the gas formed there. And if this is for chloride ion is Cl minus, that moves to the anode. At anode it loses 1 electron to form first chlorine atoms, then 2 of the chlorine atoms combine to form chlorine molecules. So we can write the equation together as 2 Cl minus, here's 2 chloride ion, together lose 2 electrons to form 2 chlorine atoms first, then they will combine to form chlorine molecules. So as they are losing electrons, so these reactions are oxidation, and we write the electrons on right hand side. For the reactions at anode, as some gases are formed there, you will see the bubbles or effervescence, because gas cannot be in the liquid. They get out from the liquid with bubbles or effervescence. So you will see there bubbles, and this is a common observation when any gas forms in a liquid. Whenever you get colorful gas produces an anode, other than the bubbles or effervescence, you also get their film, colorful film, that also happens near the anode. This is how we get the electrolyte, which consists of ions, basically react at cathode and anode and in the electrolysis. And this is simple. You need to have some practice writing equation then to make your sense very clear about electrolysis. And this video is on the basic concept of electrolysis. In the next video we are going to talk about the electrolysis where containing more than one cations or more than one anions. So there is something new there. I hope you understand the basic concept of electrolysis in this video, and you will wait for the next video to get what happens when there are many ions in an electrolyte. So thank you very much. Thank you. I hope this video has made your concept of electrolysis very clear. Thank you very much. Thank you.